Welcome back to AI Odyssey. This is episode 2 of our History of Artificial Intelligence series. In the last episode of our adventure, we explored the early days of artificial intelligence, its ambitious start, and the first AI winter. But what happened next? Today we're diving into the revival of AI and how machine learning became the fuel that reignited the field. The seeds of an AI future were being planted in the snow. Let's get into it. The AI winter, a time for hibernation. The 1980s were a wild time, big hair, neon colors, and the birth of the personal computer. But amidst all this excitement, artificial intelligence, or AI, was having a bit of an identity crisis. You see, after some initial enthusiasm in the 1950s and 60s, AI research hit a roadblock. The promises were big, but the computers of the day were, well, let's just say they weren't quite as smart as we'd hoped. This period became known as the AI winter. It was a time when funding dried up and researchers went into hiding. Not really, but you get the idea. The problem? Early AI systems were too rigid, too reliant on painstakingly hand-coded rules. They couldn't handle the complexities of the real world. Imagine trying to teach a computer to recognize a cat by listing out every single possible combination of fur color, ear shape, and whisker length. It was a recipe for disaster, or at least a very confused computer. But even in the depths of winter, seeds of a future AI spring were being sown. Researchers were exploring new approaches, new ways of making machines think. And as the 1980s gave way to the 1990s, a new era in AI was about to dawn, fueled by the sheer power of data. During the AI winter, many researchers didn't give up. They continued to attend conferences, share ideas, and push the boundaries of what was possible. One of the key areas of exploration was neural networks. These were inspired by the human brain and aimed to create systems that could learn from data. Unlike the rigid, rule-based systems of the past, neural networks had the potential to adapt and improve over time. These early experiments were often clunky and limited, but they laid the groundwork for future advancements. As the 1990s approached, the excitement in the AI community began to build once again. The rise of the internet played a crucial role in this resurgence. Suddenly, there was a vast amount of data available for training AI systems. Data centers began to spring up, providing the computational power needed to process this data. Early AI applications started to emerge, from basic recommendation systems to simple chatbots. Each small success built momentum, leading to more funding, more research, and more breakthroughs. Today, we see the fruits of those early efforts in the advanced AI systems that are becoming an integral part of our daily lives. From healthcare to education, AI is transforming industries and creating new possibilities. And as we look to the future, we can only imagine what new advancements await us thanks to the perseverance and innovation of those early AI pioneers. The AI winter may have been a time for hibernation, but it was also a time for planting the seeds of a brighter future. Today, those seeds have grown into a thriving field full of potential and promise. And as we continue to innovate and explore, who knows what incredible advancements lie just around the corner. The possibilities are truly endless, and the journey of AI is far from over. So here's to the future, and to the incredible journey that lies ahead. The AI winter may have been a time for hibernation, but it was also a time for planting the seeds of a brighter future. Today, those seeds have grown into a thriving field full of potential and promise. And as we continue to innovate and explore, who knows what incredible advancements lie just around the corner. The possibilities are truly endless, and the journey of AI is far from over. So here's to the future and to the incredible journey that lies ahead.
Out of the ashes of the AI winter, a new breed of AI emerged, expert systems. These systems were a significant leap forward from the early days of artificial intelligence, which had faced numerous setbacks and disappointments. The AI winter was a period marked by reduced funding and interest in AI research, but it also served as a crucible for innovation. Expert systems were designed to mimic the knowledge and decision-making abilities of human experts in specific domains. They were built on a foundation of rules and knowledge bases, which allowed them to perform tasks that previously required human intelligence. These systems could analyze vast amounts of data and provide insights that were both accurate and actionable. Think of a medical diagnosis system that could analyze symptoms and suggest possible treatments. Such a system could assist doctors in making more accurate diagnoses, potentially saving lives by identifying conditions that might be overlooked. Or imagine a financial advisor that could help you plan for retirement. This AI could analyze your financial situation, consider various economic scenarios, and provide personalized advice to help you achieve your financial goals. Expert systems were a big deal. They represented a tangible application of AI technology that could be understood and appreciated by the general public. Media coverage often highlighted their potential to revolutionize various industries. They were the first AI systems to demonstrate real-world practicality. Unlike earlier AI efforts that were often confined to academic research, expert systems found their way into everyday use. They were used in industries like healthcare, finance, and manufacturing. In healthcare, they could assist in diagnosing diseases and recommending treatments. In finance, they could analyze market trends and help in making investment decisions. In manufacturing, they could optimize production processes and improve efficiency. Automating tasks and providing valuable insights, expert systems became indispensable tools in many sectors. They could handle repetitive tasks with precision and speed, freeing up human workers to focus on more complex and creative aspects of their jobs. Suddenly, AI wasn't just a futuristic fantasy. It was a tangible tool that was changing the way we worked and lived. From personal assistants on our smartphones to recommendation systems on our favorite streaming services, AI was becoming an integral part of our daily lives. But expert systems, for all their promise, had their limitations. They were not infallible and could make mistakes, especially when faced with situations that fell outside their programmed rules. They were only as good as the rules they were programmed with. Creating these rules required a deep understanding of the domain and meticulous attention to detail. The process was time-consuming and often required collaboration between domain experts and AI developers. And as anyone who's ever tried to write down every single rule for a complex task knows, that's a tall order. The complexity of human knowledge and decision-making is difficult to capture in a set of predefined rules. Imagine trying to capture the intuition of a master chess player. Chess involves not just logical thinking, but also strategic foresight and the ability to anticipate an opponent's moves, or the creative spark of a painter. Art is not just about technique, it's about emotion, inspiration, and the ability to see the world in a unique way, or the nuanced understanding of a therapist, all in lines of code. Therapy involves empathy, active listening, and the ability to understand and respond to complex human emotions. It was like trying to fit the universe into a shoebox. Something had to give. The limitations of expert systems highlighted the need for more advanced AI technologies that could learn and adapt on their own, paving the way for the development of machine learning and neural networks. As computers became more powerful and data more abundant, a new approach to AI began to take shape: machine learning. This marked a significant departure from the earlier days of artificial intelligence, where expert systems dominated the landscape. Expert systems relied heavily on predefined rules and logic, painstakingly crafted by human experts. These systems were limited by the knowledge encoded within them and struggled to adapt to new, unforeseen situations. Instead of relying on handcrafted rules, machine learning algorithms could learn from data, identifying patterns and making predictions with remarkable accuracy. This was a revolutionary shift. Data became the new currency, and algorithms the new artisans, capable of sculpting insights from vast oceans of information. The more data these algorithms were exposed to, the better they became at their tasks, continuously improving and refining their models. It was like giving machines a crash course in the school of hard knocks, but without the actual knocks. These algorithms could process and analyze data at speeds and scales unimaginable to human experts, learning from each iteration and feedback loop. This iterative learning process allowed machines to develop a form of intuition, enabling them to make decisions and predictions with a level of sophistication that was previously unattainable. Think of it like this. Imagine teaching a child to recognize a cat, not by describing every detail, but by showing them hundreds of pictures of cats. The child doesn't need to understand the intricate details of feline anatomy. They simply need to see enough examples to internalize the concept of a cat. This is the essence of machine learning from examples rather than explicit instructions. With enough exposure, the child learns to distinguish the key features that define a cat, even if they can't articulate them explicitly. Similarly, machine learning models learn to identify patterns and features within data, even if the underlying logic remains opaque. This ability to generalize from examples is what makes machine learning so powerful and versatile. That's the power of machine learning. It transforms raw data into actionable insights, enabling machines to perform tasks that were once the exclusive domain of human intelligence. From recognizing speech and images to predicting market trends and diagnosing diseases, machine learning has become an indispensable tool in our technological arsenal. This shift from explicit programming to data-driven learning was a game changer. It democratized access to AI, allowing even those without deep technical expertise to leverage the power of machine learning through user-friendly tools and platforms. This democratization has spurred innovation across industries, from healthcare and finance to entertainment and transportation. It opened up a world of possibilities for AI, allowing machines to tackle tasks that were previously considered too complex or nuanced. Tasks that required a deep understanding of context, subtlety, and variability could now be approached with newfound confidence. Machine learning enabled robots to perform intricate surgeries, autonomous vehicles to navigate busy streets, and virtual assistants to understand and respond to natural language queries. And as the digital revolution flooded the world with data, machine learning was perfectly poised to ride the wave. The exponential growth of data from social media, IoT devices, and digital transactions provided a rich tapestry for machine learning algorithms to weave their magic. This synergy between data and machine learning has ushered in an era of unprecedented innovation and discovery, transforming the way we live, work, and interact with the world around us. Neural networks, mimicking the human brain. One of the most powerful tools in the machine learning arsenal is the neural network. Inspired by the structure of the human brain, neural networks are composed of interconnected nodes, or neurons, that process and transmit information. These networks can learn complex relationships by adjusting the strength of connections between neurons, much like our brains form new pathways as we learn. Imagine a neural network trying to identify handwritten digits. Each neuron in the network might specialize in recognizing a particular feature of a digit, such as a curved line or a closed loop. By analyzing the activation patterns of these neurons, the network as a whole can learn to distinguish between different digits with remarkable accuracy. Neural networks have been around for decades, but they truly flourished with the advent of more powerful computers and larger datasets. They became the workhorses of machine learning, driving breakthroughs in areas like image recognition, natural language processing, and even game playing.
The Google effect. Big data, big learning. In the early 2000s, tech giants like Google began to amass vast quantities of data, everything from search queries to email messages to online shopping history. This data deluge proved to be a goldmine for machine learning. By feeding their algorithms with mountains of information, companies like Google were able to create incredibly powerful AI systems. One of the most famous examples is Google Translate. By analyzing billions of words and phrases in multiple languages, Google Translate learned to translate languages with an accuracy that was previously unimaginable. It was like having a universal translator in your pocket, breaking down language barriers and connecting people across cultures. Google's success with data-driven AI inspired a new wave of innovation. Companies in every industry began to realize the potential of machine learning to improve their products, optimize their operations, and gain a competitive edge. The AI revolution was in full swing.
With machine learning, we're just scratching the surface. In our next episode, we'll explore how deep learning and AI are evolving today, and the ethical challenges we face as AI becomes more integrated into society. Don't forget to like and subscribe to stay up to date with our AI Origins series. Thanks for watching, and we'll see you in the next video.